Alright, so for angles outside of the circle, if a tangent and a secant, let's go back a little bit, if a tangent and a secant, two tangents or two secants intersect outside of a circle, then the measurement of the angle formed is 1/2 the difference of the measures of the intercepted arc. So in the previous examples we're talking about adding the intercepted arcs, but we're going to be subtracting its intercepted arcs. So use the space below to draw your own diagrams and write down what I draw as well. So if I have a circle and I have two secants intersect outside the circle, I'm going to label all the intersecting points A, B, C, and D. Okay? So then the angle formed on the outside is equal to 1/2 the measurement of the difference between the measurement of the outside intercepted arc minus the inside intercepted arc. So angle 1, the measurement of angle 1 is equal to 1/2 the measurement of arc BD, which is on the outside, minus the measurement of its other intercepted arc, which is on the inside, AC. So that's just one of the three examples that we can draw. So what else if we have a circle and we have two tangents? Another angle is formed on the outside. We're going to label our points P and then make a point on the outside Q, and then last one R. And we have another angle formed, we'll label that 2. So then the measurement of angle 2 is equal to 1/2 of arc PQR, which is on the outside, minus measurement of its other intercepted arc PR. Okay, so that's two tangents, this is two secants. So what happens if we have a tangent and a secant? So here's our tangent line and our secant line, label our points of intersection. So then angle 3 is going to be that angle formed on the outside of the circle. So then angle 3's measurement is equal to 1/2 of the measurement of the arc on the outside, XY, minus the measurement of arc WY. So I know my relationships of when I have two tangents, two secants, and a tangent and a secant intersect, and that angle is formed outside the circle. So then we have to find the value of x. Alright, so the value of x is here, so that's the outside, the measurement of the angle that we're trying to find. But we know the relationship of this angle on the outside and how it affects, or how the intercepted arcs are helping us find that measurement of that angle. So we write down the x, or the measurement of x, is equal to 1/2 the measurement of the outside intercepted arc, JF, minus the measurement of its inside intercepted arc, HF. So we fill in what we know. It's very important that we always write down our relationships, because sometimes we're going to have to find the value of x, which is HF, or this outside arc. So always write down this relationship, not specifically these numbers or these letters, but how the outside angle is related to the two intercepted arcs. So then we fill in what we know. We have 170 minus 172. I don't know why I'm working backwards, but I just filled in my measurement of my JF and then measurement of HF. That's equal to 1/2 of the difference of these two intercepted arcs. Simplify even further. We get 98, so 1/2 of 98 ends up being 49.